Alright, so I'm Eli, and I'm going to be talking about engineering towards a greener future. It's a pretty broad topic, but I tried to sum it up into this 30-minute presentation. And it's just like things that, little or big things that we've been making in the last decade or two to kind of go towards a greener and more safer climate future. So first we're going to talk about some simple, like in quotations, solutions to this challenge we face with climate change. So I brought up three main ones, but of course there are many, many more. First one I'm going to talk about is AirInc. So AirInc is this startup that was created in India by this company. And what they do is they take air pollution out of the air and they turn it into this rich black ink. Now, how do they do this, you might ask? They do it using Ink, which is a technology that you can put on the exhaust pipe of your car, and it collects all of the soot that leaves your car while keeping the heavy metals out of the filter. And so with this filter, you take the soot and you can liquefy it, and by doing that, you get this ink that they've made markers and just like paints out of, which I think is pretty cool. Next, we're going to do something called the ocean cleanup, which is a sea anchor that was designed by Boyden Slat, who was a Danish inventor, and he was 18 years old. And the ocean cleanup uses oceanic powers like currents or waves to collect trash and waste that is in the ocean. It does microplastics all the way to like huge bags or whatever else is thrown in the trash. And what's so revolutionary about this is that what would normally take humans 1,000 years to pick up off the oceans or to go with boats, with the ocean cleanup could take less than 10 years, which is amazing. Last and not least, I guess, so fast as I thought it would be. All right, we're going to talk about recycled clothes. And recycled clothes are bigger than you might think they are. When you buy recycled clothes, you don't necessarily know that they're recycled. So shoes are able to recycle. There are lots of companies doing it. And what they do is they take the midsole or the outsole. So the midsole is like the part here of your shoe, and then the outsole is the rubber part on the bottom. I should have taken a diagram of that, but it's okay. And those are both rubbers or plastics. And so you can take recycled rubbers or plastics, polyester, depending on the shoe, and rubbers for the bottoms, and you can take that and melt it down and remold it into these midsoles and outsoles. And so you can get these recycled shoes that are perfect or that nearly don't do anything to the environment and look just as cool and feel just as cool. Then we have jeans. There are other things than jeans, but one thing that really stood out to me. So Levi's, the biggest jeans distributor in the world. I'm wearing jeans, I'm sure one of you is wearing jeans right now. Yep, there you go. Look, it's wearing jeans. And all of their jeans created after like 2019 have more than 20% made of recycled plastic. We're gonna watch a video like right now about how that works. But what they do basically is they take these plastic fibers, which is long strands of plastic, and they can weave it into the denim. And so you don't feel the plastic, but the plastic's in there. And it uses less cotton and just so all the stuff that has to do with that. And you use recycled plastic, which is awesome. Now, how do they do this? So they're gonna take these plastics, and we're gonna watch a video about this later if I don't explain it perfectly. So they're gonna take these plastics, they're gonna take them into these really, really small little shards by melting them and shredding them. And then when you get it into this liquid or not extremely solid state, they're able to blow it out into this really, really small thread, which can then be woven into sheets, which can be made into clothes. So since I didn't do a great job explaining that, I'm gonna play the video. Let me get to the right time then. Big time. No. Just a second. Thank you. Yes?
Should be good. Was it?
Right here, left.
Further down a bit.
Goal is to get it ground up really small so we can make a barrel out of it, but there's a lot of water.
You put a bit louder.
To make sure that it goes through so that it's clean.
Right. No, to this one.
kind of cool visual, but it also shows how they're cleaning it and sorting it for different colors.
We're going to walk into the facility, seeing exactly how it gets broken down to make all the threads that end up going into these shirts right here. These are the shards that get broken down to the plastic bottles that ultimately go into these shirts. The plastic gets grinded down through the machinery. And so these small samples, what they do is they bake these and they heat them up to find the imperfections to make sure that these shirts and the fabric, the cotton that's coming out is the highest quality possible.
So you have these shards, and the process they don't show you here is how
So
you
the next
pull them
step of the
out.
process
But
is the yard actually
Yeah, the yard.
getting weaved together to make the fabrics for the shirt.
so this looks, it's the exact same process as a normal clothes manufacturer, but they're with plastic instead of like cotton, which is
So
different.
all this recycled yarn is going into these machines and making spools that can create 70 shirts per roll. And they'll
And so then they keep on going, but I don't think we need to watch anything else.
70
Next.
Escape.
Escape. Oh,
Oh,
working it, right?
Sorry.
Oh, it's down there. All right. So does anyone have any questions about those simpler solutions compared to what we're going to see there? Nicola.
Yeah, for the working of the air ink, do you know how they like take the pollution and make it into like proper ink?
Yeah. So for air ink, what they're able to do is they take the soot out of the cars through this cowling thing you put at the end of the exhaust pipe. And then what they're able to do is they melt the soot into this little liquid, and then they're able to put chemicals in it which make it a better like ink consistency, and then they're able to put it in pens.
Yeah, but so like they don't take it from the air, like they put it, like they
No,
put
that's what
these
he-
things on the
Yeah,
cars.
they put it on like exhaust pipes and like around the highways.
Okay.
So instead of your car like releasing CO2 into the air, it's like
Other questions? Yes.
Do the ocean thing catch? How is it called? The ocean.
Ocean.
The ocean cleanup catch fish.
It does not catch fish.
Does not. How
It
does
has-
it?
It has this, it's only on the very, very top, so it gets the
Okay.
things that are able to hold air, and the fish are underneath. I'm pretty sure. No other questions?
what's the name of this? Yeah, like, is it just named
It's the ocean
now?
cleanup. I don't know exactly what the invention's called, but it's ocean. Now is,
Yeah, just for the ocean cleanup, but wouldn't it be like it's good for small places, but you cannot put like thousands of ocean cleanups everywhere because then it would be like impossible for fish or like even humans to go in the sea.
yeah,
It's
it's,
like a small part answer solution.
so the way, ocean cleanups work is this is its anchor, and since it's in an ocean, it can't go down far enough, so actually the nets aren't anchored. They kind of drift around, and so you're able to get this like parachute full of trash, and then someone can come and just replace it when it gets close enough to land.
It can move.
Yeah, it moves around, so it gets everywhere without having one in every place.
Okay.
You don't need to like cover the whole ocean with it. It wouldn't even work because the way it collects trash by moving and taking it into the back. So.
Okay.
Other questions? All right, now let me switch devices, or switch slides. Because this tick, so it's not. I apologize for my quality of.
Just search this.
Get there eventually. Oh, there we go. All right.
Actually search the website URL.
All right. So we're back to engineering towards a greener future, part 2. And in this section, we're going to be talking about green energy. So who knows what green energy is? Nicola, go for it.
I think it's like renewable energy that cannot be like exhausted and it doesn't like, we don't have to extract it from the earth, like it doesn't hurt the earth when we use it.
Yeah, go for it.
It's just the energy that doesn't emit greenhouse gases.
Exactly. Nicola, you used the term renewable. What does it renewable mean?
It means like that you can use it like forever for when if the things that make it work, like use, or like if there's still light for the sun, for example, it will continue. Like we don't have to have a limited resource.
Exactly. And that's, yeah, exactly. So with green energy, you try to use things that don't go away. So fossil fuels go away, but as Nicholas said, wind and light don't go away. That's the whole point. All right, so we're gonna talk about like different ways to make green energy, or like green energy, like different renewable energy sources. First, we're gonna talk about is wind turbines. Does anyone know how wind turbines work? I'm gonna go back so that you guys don't see the answer. Go for it.
They use wind to make a movement that then the movement creates energy.
Exactly. Do you know how? Sandra?
Might want to explain it.
I will.
No, I know, like,
It's magnetic sort of.
It is magnetic, exactly. So here in this diagram, you can see basically the way it works is there's this turbine, and the turbine spins. The turbine is just the rotor in this, and the turbine is attached to the shaft, and then the shaft goes into this generator. And in the generator, there's a huge copper coil. It's wrapped around a lot of times. And inside of the copper coil, there's a magnet, just like I just said. And so by taking all this kinetic energy of the turbine spinning, or in this case the blade spinning, you're able to take this kinetic energy and through electromagnetism, we're able to make it into electric energy, which can then be converted to DC energy, or AC energy, sorry, which can then go right to your house. Question? Yes?
Yes, but if it's like that easy, why don't we have so many of these turbines everywhere?
One, because it's expensive to build, and two, because it's like not really that easy. I'm simplifying.
Okay.
3 people don't want it near their house.
Yeah, exactly. It's noise pollution and it's just uncomfortable and kind of use.
Is it also because like it doesn't produce that much energy, and because like if there's no wind, there's no energy. Like it would be difficult that all our energy would depend on the material.
Yes, but I think it creates enough energy that you're able to get a reserve of it.
Okay.
So if there were to be like one wind turbine per 10 houses, let's say, which is not a lot, you'd be able to get a huge reserve of it. So even if there was a day where there was no wind, you would still have all this energy that you could be using.
Okay.
But is it really green energy?
What?
Is it really green?
That's the problem with wind turbines, especially. Wind turbines, the cost to make a wind turbine is about half, like the electric cost to make a wind turbine is about half as much as it produces. So there are questions about it being extremely green. All right, next we're going to talk about, next we're going to talk about hydropower. So hydropower is very, very similar. Let's copy this. Blade spin, but in this case it's a turbine that's in the water and it takes the tides and the current to make the blade spin instead of waiting for sun. And it's the exact same system. I use the exact same diagram. It makes the rotor spin, and there's a coil, and the magnet spins, and that creates electric energy.
What would you say is the difference, except the fact that it generates, like the water affects one and the wind affects the other?
There's very
It's
little
exact
difference.
same.
There's very little. Now we're going to talk about nuclear power.
Yeah.
Go for it.
Yeah, just which one of the two produces the most energy? Like which one is the most effective?
They're about similar because it's the same technology in the generator, but the tides are more constant because wind, as you said, can stop for a day, but tides can't stop for a day.
Yeah, because we can like block water and let it flow when we
Exactly.
want.
They're most paired dams. Right, block. All right. Nuclear power. This is what's mainly used in France, and I took the exact same diagram again, and I took a GIF of how it works. So the way it's going to work is you're going to have this water, and you're going to have this cooling liquid, which happens to also be water. And so what you're going to have this reservoir of water, and you're going to pump it by a condenser, and this condenser is going to push it right on top of this flame, which is created by nuclear power, like by nuclear flames. Heat, not really flames. And with this heat, this water that's been cooled down by the cooling liquid, which cools the water down, is going to create steam. And that steam will have nowhere to go but up. And at the top, there's going to be this little tube. So the steam is going to keep going up, until it hits the tube, and it's going to keep on going. And then, again, there is a turbine. You saw that one coming. And so the steam is going to spin the turbine, and the turbine is going to spin the shaft, spin the generator, or spin the magnet in the generator, and create electricity. But the steam is then able to go back down it goes over the cooling fluid again, and that cooling fluid makes it water again, and the whole system repeats. And that's what's so cool about nuclear energy, is that you get this discharged uranium, but other than that, or actually not other than that, that's a big thing, but like the water stays housed, and so it's, yeah.
Yeah, how do we get a discharge of uranium?
So to get this heat source,
Oh.
you need to create that nuclear power, or the nuclear energy, and with that, and to get that nuclear energy, we take uranium. Alright. Now we're going to talk about geothermal power, which is very similar to nuclear power. Actually, it's really the same, just slightly different. Geothermal.
Does it produce less than nuclear power?
Yeah, it produces less nuclear power. And also, you can only do it in certain parts of the world because you need your geothermal sources. So in Iceland, there's lots of geothermal power. In other places where there's a lot of geothermal distribution. So the way it's going to work, very similar, is you're going to take this water reservoir. The water reservoir is going to be heated because of the geothermal properties. It's going to go up, it's going to create steam, it's going to spin a turbine. The turbine's going to spin, it's going to go back down, it's going to be cooled down, it's going to go back into the reservoir, it's going to be heated up, it's going to go around, it's going to go around. Like that, it spins up a turbine, which spins the magnet inside of the generator, which creates electricity. Yeah.
So all these
are exact.
all these work the exact same.
Yeah, pretty, or, yes.
But then not like the functioning of actually making the electricity is.
Yeah,
pretty
that's what I'm trying to
different.
get you to realize, exactly.
But so the water in one circuit is always the same. We don't change it not even each 10 years.
I'm sure you change it because some can get lost, and
Okay.
so you're replacing some, it's just like a safety hazard, but yes, ultimately.
So do we have any other way of making electricity except the diagram?
We're gonna get to that.
Okay.
So what's the main source that we haven't talked about? Huge source, yeah.
Cool.
Coal.
So-
How about green?
Solar.
Solar, exactly. So how do you guys think solar works?
Thermal energy.
What? Thermal energy?
No,
Yeah.
no.
Using this pattern though, how do you think it works?
Oh,
It does use this pattern.
It doesn't use this pattern. That's the little trick. Alright. So solar panels, these are completely different and they're frankly quite confusing. So solar panels, light, what is light? Broad answer.
Photons.
Photons, exactly. Photons come from the light. And these photons, when they hit the photovoltaic cells, which is what solar panels are made out of, they take the silicon atoms and they can knock out the electrons from the silicon atoms. And so these electrons are now free, and they're in between layers. And so these free electrons, what do? We're not in the same class, never mind. So these ones are,
Right, yeah.
I thought we were in the same science class, so.
no. Free electrons do. Well, they're basically how an electric current work.
Exactly. And so you're gonna have these free electrons, and at the end of the solar panel is gonna be a condenser rod right here. And so all of the electrons,
What?
and so all of these electrons are gonna be attracted towards the condenser rod at the end. And so what's gonna happen? The electrons are gonna make a flow, and what is the flow of electrons? What's the flow of electrons?
Electricity.
Electricity, exactly. So we have this electricity, it's direct current electricity, because they're all going in the same direction. And so you're able to convert it to AC current, the same way that they would in generator, or like after a generator. Yes?
Yeah, but would it be useful to combine this with the solar energy with the nuclear? Like for example, we use the solar energy to heat up instead of the uranium, so the nuclear isn't dangerous and doesn't pollute. And so then the solar can heat up the water, so that's working like green energy.
It would. The problem with it is that the sun, it's tough to make the sun that hot. Because the sun needs to boil the water, and it's tough for like it to be 212 degrees or 100 degrees out.
No, yeah, but like we could use some kind of green energy model to heat the water.
Yeah, absolutely. Yeah, I agree with what Nico said. I think currently you could use plasma to create artificial suns that are actually
No, exactly.
hotter than the sun.
That's what nuclear power is.
Exactly. So why couldn't we use that?
No, that's what nuclear power is. We talked about that.
Yeah, but why can we combine that with,
Because the sun, where it is with the atmosphere, isn't strong enough to heat up the water to make it boil up to steam. Because then we can power the turbine, which
Right. Cool.
Alright, so that's how solar panels work. They knock the electrons free. It's clearly not exactly what happens, but in face what happens. It creates current, it's attracted to the wire, and then it goes to your house. Alrighty, now it's your turn. Michael, you came in at the perfect time for this, lucky you. And so you guys are gonna try to create some invention that can make our world a little bit greener. I don't know what you're doing. Awesome. I'm gonna give you like 15 minutes to create some cool invention that makes
I
the
think a
world
bit
better.
less than 15. Okay.
10 minutes, yeah, 10 minutes. To make the world a better place.
Great.
Great. Oh, okay. Alright.
Can we
Yeah.
start?